Welcome to today's presentation on the benefits of using SQL Common Table expressions. My name is Marcy Lentz, and on behalf of ProTech Training, I will serve as your host today. Before I introduce you to our guest, just a few housekeeping items. This presentation will last approximately 45 minutes with additional time at the end for Q&A. During the webinar, feel free to enter any of those questions into the Q&A area of Zoom. Today's presentation is being recorded, and in the coming days, you will receive an email with the recording link. Now, a little bit about our guest. John Mullins is an IT professional with 40 years of experience in the field as an application developer, database administrator, and technical instructor. While working for companies such as Boeing, DRT Systems, and CGI, John is an Oracle certified professional DBA and certified technical trainer and has taught over 500 classes at all levels over the years. Without further ado, I give you John Mullins.
Thank you, Marcy. Well, good day to everybody. Thank you for joining us today. I'm excited to see all of you today, although I can't really see you, but I can see you in the queue there. So thank you for joining us again. Today, we're going to be talking about common table expressions within SQL. And so we'll jump right in and get started here. I know everybody's very busy and needs to get on their way here shortly, but let's take a look and see what we got going on. All right, what are we going to talk about today? Well, for one thing, what is this thing called a common table expression? Maybe all of you know, maybe some of you know, maybe none of you know. I don't know. Well, I do know. But what is a common table expression? That's what we're going to do. So we want to see in syntax wise, what does it look like so that we can recognize that out there. And so we'll see what it looks like syntax wise. And what we're going to find out is it's just another syntax coding technique that can be used as an alternative way to get to some answer. So we know that with SQL, just like any other language in SQL, there could be more than one way to get the same answer. And it's no different here when we talk about common table expressions. This could pop up as an alternative. And anytime, it doesn't matter the language, but anytime we come up with, or at least even think of, without even trying it, think of multiple ways to get the same solution, then we have to kind of wonder, well, is one way better than another way? And that's where we start to talk about the benefits of each way that might be. So we're going to talk about those today. So we'll talk about a few things. One is, here's what they look like. Okay, great. Maybe we already knew that. The second thing is, what are some of their benefits? And then we're going to be looking at code. So I'm going to kind of switch back and forth a little bit today between the slide deck here and also into an environment where I can actually run the code. So for each of the different benefits, we'll look at a piece of code and say, hey, what do you think of this? And for example, maybe readability could be one of the benefits. Well, let's look at some examples to see for readability. Do you agree with that or not? Now, of course, when we talk about benefits and such, everybody kind of has their own view on that. It's like, well, do you think this is more readable than that? And so one person might say, oh, I certainly do. And the other person will be like, nah, maybe not so much. So we'll keep that in mind too when we look at those. So we'll look at lots of pieces of code here as we go through here. Then we'll kind of summarize at the end. And as Marcy said, if you have any questions, you can put those in the Q&A up there at the top. And off we'll go here. All right, so we're going to start off with here to just look at a couple of examples of what a CTE looks like here in just a moment. So let's go ahead and jump over to there real quick. Now, as we look at the examples, we'll keep these things in mind. Common table expressions, different people call them different things. Some people might call it a common table expression. That's kind of the long version of it. Other people might call it a CTE or SQL with a with clause. Or here's something that sounds pretty impressive, right? How about a subquery factoring clause? You know, that sounds pretty good. You know, you go home at the end of the day and people at home, they kind of say, how was your day? You know, what was going on? What'd you do today? Oh yeah, I worked on subquery factoring clauses all day. Ooh, okay, that sounds pretty exciting. But to know the different expressions that they could be called, that's important because we want to keep everybody on the same page. You know, what we like to avoid is, and I talk about this in the work environment all the time, is you're working on a particular project, a particular report, and you run across one of your coworkers either in a Teams meeting or back at work in the office, and they're asking you about your project. You know, how's that project going? I hear you're working on some pretty complex SQL in there. Are you working with any CTEs in there? And your answer might be, well, no, I don't think so. No, but I am working on some common table expressions. Okay, well, that's the same thing. So we like to throw out these other ways that a common table expression could be called there. So just keep that in mind there too. You know, what is a real simple definition of a common table expression as far as we're trying to describe what it looks like in the code? Well, it says here on the slide, it's defined at the beginning of the entire query and then is available for the duration of the query. I would probably change that just a little bit. Rather than saying defined at the beginning of the query, I would say defined before the entire query, before the main query. How about that? Something like that. Sometimes the terms can get a little bit, there's some overlap there when we talk about, you know, subqueries, for example. We talk about main queries and subqueries, or outer queries and inner queries. This is a little bit different, but sometimes people use the same terms for those. So we'll keep that in mind as we go through here too. All right, let's look at our first example here. All right, what's it say here? It's always good to kind of put, you know, what the code is trying to do here. So it says what? Display the department with its total payroll. So we're going to show a department number and the total payroll for that department, but only for those departments, if they have the same, the highest payroll. So what departments have the highest payroll? I want the absolute highest, the number one. I don't want the top three in this case. I just want who has the highest payroll there. And this is just, we'll look at this code a little bit more, or code similar to it, as we go through the presentation today. So we won't do that here, but here I just want to throw out there right off the bat. I know some of you are familiar with common table expressions, and some of you maybe aren't, and everybody else is in the middle. So some of you may not even know what the code looks like. Now you may look at this and say, oh, that's a common table expression. I always called it this. So here's an example of that. Now, when we look at it on the screen, just to point out a few things, you know, here it is, like we saw on the previous slide. It says what? The common table expressions defined before the main query, or before the entire query, whatever you want to call it here. And that's what you see here. And it's defined with that with clause up at the top. We're going to see some examples later on of having multiple entries up there also, either independent entries up there, or one entry that depends on another entry up there also. We'll take a look at that a little bit later also. So one thing that, if this is something new that you're looking at, maybe you've seen them before, or but you haven't used them before. This, if we look down in here, let me get my little annotator here going. Bring that up here. Right here, this little gap between the two things. I put a little green check mark there. You don't have to have a gap there, but it makes the code a little bit more readable if we do, so we can kind of distinguish between what is the CTE and what is the main select below there. So sometimes it can get a little bit jumbled up there if that blank line isn't included, but by having the blank line, some people may look at this and say, well, that's two statements, right? I run the with, and then I run the select down below. And this is actually all one statement. You know, if we're just talking about the basics of common table expressions right now. So that's all just one statement that we're looking at there. That's all one thing. In fact, let's go over here. I'm going to clear that off there, and let's go over to our IDE, or our work environment here, and let's just run this, because it's always good to kind of have, okay, what's a description of what the code does? What does the code look like? And then what is the result the code produces to try to get to understand these things? So let's go over here. You should all be able to see that there. Here's the same piece of code right up here at the top. I'll highlight it there for just a moment there. So I have a common table expression here. Up at the top, if we're just talking about syntax for now, what we're trying to do with these, and we're going to get into the benefits in a moment, but I'm going to go ahead and start talking about them now, is we're trying to simplify and make our single piece of code more readable for sure. Now, these are part of the SQL standards for the industry that are out there, and they're available to really all the vendors, and most of the vendors have implemented these, and a lot of them have implemented them the exact same way. So if you're if you're an Oracle person, a DB2 person, SQL Server person, any of the kind of the big three, not to leave anybody else out there, but they all support this. So if you're here wondering, oh, I wonder if this is just an Oracle thing or a DB2 thing, no, all those vendors all support this. Postgres also does this. Theirs is a little bit different, but Postgres also supports this as well. So what we're trying to do is, originally, and you'll see some of this later on, this particular subquery up here, I'm just going to call it a query because it's not really a subquery anymore. We can call it a subquery, but it was a subquery at one point in time. When was it subquery? Well, down here, when we were just trying to display a department total, and down here, when we were trying to compare it to something. It appeared down there as something much more complex. These today are going to be pretty simple examples, but we're trying to get across the concept of using these and what their benefits are. Back there at work, I may have a subquery down here in my main query. I could have it in here anywhere. I could have it up here in my select expression list. I can have it in my from clause. I can have it down here in a subquery in my where clause. I can have it in any of those places. And the subquery down there, it might be 25 lines of code. And oh, by the way, it shows up down here, what, 1, maybe 2, maybe 3 times. Now, it could be a slight variation of it because it could be when we move it up here, it becomes a non-correlated subquery versus a correlated subquery. Non-correlated subquery is just a select statement within some other SQL statement that can run on its own independently. It doesn't need any help. It doesn't need any input from any other part of the query. We can always test things like if I came up here and just highlighted this code up here and ran it, if it runs and give me results like we can see down here at the bottom, then I can call that a non-correlated type of query or subquery at that point. Okay, if it needs some help and it looks like the subquery or the query looks like it's doing a join, then we're going to talk about correlated. We're going to see some correlated ones later on today for sure. So what we try to do is we're looking at this code down here and we're thinking, that's just a mess down there. I have multiple subqueries. The subquery itself is complex. In addition to the main query is complex. And I want to try to make it more readable because, as you know, back at work, we share code. Yeah, we don't always write code from scratch. You have your own code that you've used in the past. You have it saved somewhere. You have coworkers that have code that's saved somewhere. Maybe that's shareable between everybody there. I may come to somebody like Andy and say, hey, Andy, I hear you have some code that kind of does something like this. I'm kind of working on something similar. Can I use your code and use it as a template and customize it and change it? And, that saves me a lot of time, doesn't it? So that's the whole point of this, is pulling stuff out of here to make this more readable. So we put it up here. So the focus is on, I can see the queries up there, and it makes this main query down here much simpler. Okay, that's what we've got going on there. So there's just a real simple example of what's going on here. This subquery, if you see it, it's summing up the salaries plus bonuses for each department. It's getting the total payroll, or the total financial information for each department up there. And then I'm going to use that down here somehow, right? Either in a comparison or otherwise down there. Okay, so I'm saying that's a basic one. That's a simple one. Okay. If we go over here, let's go to another one. This one's saying, oh, this is a complex one. Well, it's complex within the outline of today's presentation. Maybe not so much in your work environment, but just looking at it, you might think it's more complex than the previous one. You know, what's this one doing? Hey, let's show all the departments along with, and we're going to see this one a number of times later too, when we're looking at it with the benefits here. Show all the departments along with the number of people or employees in that department, and along with the number of projects they are responsible for. All right, it says display the department even if it has no employees or even if they have no projects that they're responsible for. Now, anytime we see kind of a statement like that or hear a statement like that, what are we thinking? Yeah, outer join. And you can see that down in here. We've got some left outer joins in our code. All right, so you can see those both down in there. Now, this is an example of, we have our with clause up there, and it has multiple entries in it. Now, that's why I'm calling this one complex. So you can see it here. We give each entry up there a name. These are not great names, are they? With X as, and then here's the query that goes with it. You know, it's getting what? The number of employees by department. That's all it's doing. And you might be thinking, as you're looking at this, like, well, I know another way to do that right off the top of my head. Yeah, you probably do. We already talked about that. There's usually more than one way to do this. This is just another way. And you want to use this way if the benefits that we're going to outline here in just a few moments, if they apply to your environment. You know, sometimes you'll see here's an alternative, here's an alternative, here's an alternative, and you look at all three, and you know your biggest concern is performance, and then you might also have a concern for readability, but probably performance first. Well, what if they all perform in a very similar way? There's not one that's decidedly faster than the others. Okay, so they're probably equal on performance maybe. What about readability and the way it looks? You know, you might think, oh, this looks much more readable than some other way, but somebody else may look at it and say, nope, not to me. It doesn't look any different there. So what do we got there? We got with X, which is a terrible name, and then with Y down here. We have two of them. Y is doing what? It's getting the number of projects the department's responsible for. Now, the way this works behind the scenes is each of these queries defined up in our common table expression list, they run basically first, and they put a result set out in memory with a pointer to it. Okay, some people might call that a cursor. Some people might call it something different, but what it actually is just the result set is in memory with the pointer to it there, so to its address. And we have those up there. So they run once. It's kind of like a non-correlated subquery runs once. These run once, get the result, put them up there. Then from there down below, the main query runs. And here you can see what they're selecting. They're selecting the department number, the number of employees, and the number of projects. So right here's the number of employees and number of projects. Well, where are those coming from? Well, they're coming from X and Y. Where's that at? Oh, that's defined up here with X and Y. And then inside these up here, we gave the count of the number of employees and the count of number of projects right here. We gave them an alias. Now, was it required for us to give them an alias in this case? The answer is yes. Okay, here's our query. We could run that query. If we were to run it by itself, we would not need an alias. But in this context, it needs an alias. Why? Because it creates, you know, just like when we create a view or we have a nested table expression, which is totally different. We have this expression up here with the count. And what's in that expression? It has parentheses in there. That's the main thing in this one. It has parentheses there. It has parentheses down here. it tries to make, it wants to give a name to that expression. Well, names, it's not valid for a name to have a parenthesis as part of that name. That's not valid. So if you try to do these without the aliases, you'll get an error. All right, we have to follow the standard, the acceptable naming conventions for any type of object, right? Whether it's a query, a subquery, a database view, or whatever it might be there. Now, look how simple our main query is down at the bottom. You know, we're selecting some things and selecting 3 expressions up above from 2 tables. Now, since we have 2 tables, well, they look like tables, right? X and Y, we have to join them. And that's what we do down here at the bottom. So they have to have something in common in this type of query. And they both do. They both have department number there. They don't have much else. I doubt if unless it's just a coincidence that the expression for the number of employees and the expression for the number of projects, you know, maybe they'll have the same count, but that doesn't sound like something we should be joining on. That's not a good relationship there. So we're going to join on department number here. So this is just a simple expansion on what we saw with the basic example just a few moments ago. All right, so like I said, we'll get into these a little bit more. These first 2 are just, oh, by the way, here's 2 of them in case you haven't seen them before. So let's take a look at some of the benefits now, okay? So let's go ahead down here and do that. We'll go over here to the next page. All right, first benefit, readability. Okay, that leads us into maintainability. Okay, so like I said, you saw those other ones and you may have been thinking in your mind, oh, I normally do it a different way. And why do you do it a different way? Well, maybe because you think the other way is simpler, is more readable than this way. Other people might think the opposite. Okay, but remember, we're pulling things out of the main query. And think about, like I said, think about back at work, your subqueries are more than 1 or 2 lines probably. All right, so here what we can do is take those pieces of code from down below and do what? Move them up above, break them into smaller, more manageable pieces of code that we can focus on up. It gets a little bit cloudy, doesn't it, when it's included or embedded inside the main query. Let's pull them out so we can focus on those, especially if we're having a problem with those. You know, that might go into the maintainability, or if we're trying to troubleshoot a problem here, we may want to do that. So, you know, readability is a big thing, but readability is kind of subjective. Like I said, it might be 50-50. Some people think it's better, easier to read this way or otherwise. Now we know we're going to have alternatives, and we're going to see those towards the end of the presentation today. You know, which one do people choose first? You know, alternatives could be a nested table expression, could be a database view, it could be a common table expression, it could just be using subqueries directly. There's 4 different alternatives there, and you get a problem to try to solve. You know, what's your go-to technique? What's your go-to syntax that you like? Is it a common table expression? I don't know, probably not though. A lot of people choose some of the other ones first, and that's okay. I'll talk about that when we get to the performance benefits that these may give us there. So, you know, this is one of our goals here. If we can accomplish this, we're doing some good things. We talked about when we pull the subquery out of the main query, we put it up above in the with clause. Down below, we can now refer to it 1 time, 2 time, 3 times, however many times we want. And each time we're referring to the shared memory segment where the result of the the query from the with clause or the CTE is up there in memory. So, you know, we can reuse the result set. Now, some people also call, you know, a common table expression a named result set. Now, that might be a good way to describe it as well, but I think that's a little bit fuzzy. You know, what do you mean by that? We're talking about the result being in memory with a pointer to it, and we can refer to it, you know, as many times as we want. It doesn't have to redo it. It doesn't have to rerun it. Yeah, which then leads us into the performance benefit that we see here. This can be a big deal. Okay, this can be a big deal here. Is everybody going to realize a performance benefit by using a common table expression? No, they're not. It depends. When we take it out of the main query and put it up above, maybe that helps readability wise. Check, okay, that's one of the benefits. But are we going to realize a performance benefit just by doing that? And the answer is maybe not, or maybe even no. What if we only refer to that subquery or that subquery that we moved up to the above part? What if we only refer to it one time? Well, we're not going to get a benefit performance-wise from that likely. Might be slight, might be none, but it's not going to be noticeable probably. Okay, so the big benefit is if you've got a query that refers to some subquery multiple times in the select expression list, in the from clause, maybe multiple times just even in the where clause, in embedded subqueries down there. That's, and you take those out and move them up above. If it, we'll see these in some examples in a moment, but if it was running those subqueries, 2, 3, 4 times down below, then moving it up, it only runs one time. And we refer to the result set from it. Boom, that's our performance benefit there. I've had people from class that see this sometimes for the first time, and they're like, you know what? I think I've got a query back at work that this might help with. And they go back and try it. And I get emails all the time from people I work with from classes or consulting, and they'll send me back an email and say, hey, you know what? I changed my query to a CTE, with the idea that I could get added performance, and I'm getting 40% faster now. That was an actual case from somebody. They're getting 40% faster now. Almost everybody who sent me back, they have an example at work where they refer to the result of the subquery multiple times. And pretty much every time, I can't think of anywhere it wasn't, they sent me an email back saying, hey, it's faster. I haven't never gotten anything back from somebody saying, oh man, it's a lot slower. I've never heard that from anybody. But, in some cases, if you pick the wrong query that's only referring to it once, then it might be the same, but it's not going to be half as fast either. Okay. Now, when we look at these for the performance stuff later, I'll start running some of these through code, through our interface for code there. I'm going to run some of them through the explain plan utility. If you're familiar with that at all, and some of you are, some of you not, but explain plan utility is something you can pass a query to and say, hey, if you were to run this query, how would you do it? What's your plan? Remember, every SQL statement, this kind of goes into the SQL tuning aspects of it. Every SQL statement gets an execution plan. It doesn't matter if it's DB2 or Oracle or SQL Server or whoever, they all get execution plans. And that plan is usually decided by something called the optimizer. Sounds like a cool job title, doesn't it? That's better than application developer. Yeah, I'm the optimizer. That sounds pretty good, but it comes up with that. It has a pretty important job, doesn't it? Pretty important responsibility. So it's going to go out, and the explain plan utility will ask the optimizer, how would you do this? And it shows us the plan. And then we can decide, hey, is that a good plan, a bad plan? But it can open our eyes to maybe some problems. If we do have alternative ways to come up with the same solution, maybe we could run all of them through the explain plan utility and see what some of the differences are. All right, so we'll kind of look at performance just a little bit more here coming up. All right, so here's a readability example. And this is where I want to start, jumping over and looking at the code. Take a look at that. Okay, you might be looking at it like, so I'm looking at this one thinking, where do I start? Because it looks like all the code is just in a pile, doesn't it? And we can format the code a little bit differently to make it more readable too. I want to stick with it. This is a nested table expression. I like nested table expressions. This is the way I'm going to code it. And so I'm probably going to format it a little bit differently so it's more readable. But you can see this. What is a nested table expression? Well, instead of having those subqueries that we pull out and put them up above in a with statement, in a with clause, in a CTE, the query itself is embedded right here in the from clause. So this is a nested table expression or an NTE. Right now, I'm just looking at some of the alternatives so we can see the differences. And this first expression, you see here, it's included in parentheses. We give it a name, and it's going to be, here it is again, called X. We give them better names at work, right? And then down here, after X, we have a comma. So down here below, we have what? There's Y. Here's another one. So we kind of treat these as, hey, X is a table and Y is a table down below here, right? Or database view or whatever you want to call it. But since they're in the from clause, we treat them as such, right? And then since we have multiple items in the from clause, X and Y, we have to join. You know, if we don't do join there, what happens? You know, we're trying to strive here for readability and performance, but if I don't do the join and with this type of syntax, then I'm probably going to get a Cartesian product, which means every row from X is going to match to every row from Y, and that's a problem. Right? So this is just kind of to throw that out because today's topic is not nested table expressions. It's common table expressions. So here's this solution. This is one we saw earlier. Show me the departments along with the number of employees and their number of projects. So if you remember from earlier, we saw that as a common table expression. You can take this pile of code and look at it this way. Here's the same thing. And now, I don't know, does this way here, does it look any more readable than this way here? I don't know, you might look at this way right off the bat. And when we say more readable, we're also making the assumption that we have some knowledge and comfortable we are a little bit with common table expressions. Because you might look at this and say, well, it might be more readable if I knew what that width was up there. So we're kind of assuming that, hey, we kind of know what a CTE is. So does this CTE here, that's hard to say, is it more readable, more understandable? And we have to kind of think in terms of maybe somebody else looking at it, because you're looking at it and you wrote it. So you're like, oh yeah, I know this inside and out. I understand it. That's very readable to me. But what about one of your coworkers? Is it very readable to them? Maybe, maybe not. Right? Remember, that's one goal. Now, the committee, the American National Standards Institute Committee, ANSI, who came up, this was part of their standard way back when they came up with this standard, really the only benefit that they were thinking about was readability. How can we make the queries more readable? Let's pull the subqueries out and define them separately. That's what they were thinking about. They weren't even thinking about performance. You know, that just happened to be kind of a side effect of some feature. And that happens a lot. You know, sometimes that comes up that way. All right, so there's two ways there for readability. Now, here's where we really want to look at it, because it's like, okay, readability is kind of subjective, right? But performance really isn't. It's either faster or slower or the same. It's not, I guess sometimes we have kind of what, a perception that, well, that seemed faster. I get that all the time. I do a lot of work as a DBA. And somebody will say, hey, I was running this yesterday and it seemed to run pretty good. I'm running it today and it seems slower, or it seems faster, or it's a lot slower. I hear that sometimes. They don't usually they don't usually come to the DBAs and say, hey, this is fast. They usually only come to the DBAs when something's slow or slower. So they may come back and say, oh man, this is at least twice as slow as yesterday. And, you know, as a DBA, depending on which environment you're in, Oracle, whatever, we have tools that can kind of measure the performance of queries. And, you know, and we can also look at the results of queries that have already run. Oh, maybe they ran this morning at 8 o'clock. Now it's 10 o'clock. And they said it was, you know, twice as slow at 8 o'clock. You know, all that stuff, and all the vendors, DBAs have access to those numbers to see, well, what happened at 8 o'clock? Let me go back and look at your query from 8 o'clock. I'm not going to run it again now because that's not the same as running it again at 8. Let's go back and look and see how it ran at 8. We have ways to do that. And we look at it and we look at the numbers and then we go back and see how it ran yesterday. We can do that too. Specifically in Oracle, we can go and look at that. Oracle keeps a lot of the statistics for things that are running by default for up to 8 days. And that could be changed to be longer or shorter, but by default for 8 days. So I'm going to look at your run from this morning at 8 o'clock and look at your run from yesterday at 2 o'clock. And guess what? When I look at them, you said this morning was twice as slow, didn't you? Yeah, that's what I said. It seemed really slow. Well, I'm looking at the numbers here and it's actually a little bit faster. There's lots of things that change our perception on things, isn't there? The way we look at them, and these could be one of them. But look at this query here, and we're going to run some of these here since we're on the performance part. Display employee individual data. A lot of times we go to subqueries when we want to display individual data along with summarized data with queries. It says display employee individual data along with the average salary for their department, but only for those employees who make more than the average salary for their department. All right, so what do we got going on here? Let's take a look at it. I highlighted in red there some of the tables that are being accessed here. So let's take a look at it here. Let me get my marker. So we're showing the employee number, their job title, their department number, and their individual salary. That's the individual data for any particular employee. Along with, there's a comma there, I want to show also, here's a subquery. Select the average salary from EMP, from the employee table, where the employee number or employee department number in that table equals the employee department number from the main query out here. So I'm kind of joining two queries together, or the results or the data from two queries here. This is an example of a correlated subquery. Now, what do we know about correlated subqueries? How many times do they run? Well, we said with the CTE, the queries up above only run one time each. And the non-correlated subqueries only run one time each. This guy down here getting the average salary for a particular department down here below, it may run multiple times. You know, every time I get an individual record from the employee table, this department number here, I'm passing it into the subquery here. And if it's a different department number than has been passed before, that subquery has to run again. So that's one of the bad things about a correlated subquery, isn't it? Or potential bad things, let's say it that way, that they could run millions of times depending on our volume of data and the distinctness of our data there. So, you know, that little subquery there, just to display the average salary for that person's department for all the employees, likely has to run multiple times because we have what, multiple departments for our employees. So that's one bad thing here, right? This correlated subquery running multiple times, accessing the EMP table, right? The main query is also accessing the EMP table here in this from clause in the middle. And then what are we doing? We're comparing their individual salary against what? The average salary for their department. Oh man. I mean, take a look at that. This doesn't sound, I mean, it works. We're going to run it in a second. It works. But what do we got going on here? I have a main query on the outside, which is feeding the subqueries on the inside. This subquery up here runs multiple times. This subquery down here runs multiple times. And then, of course, I have to access the employee table from the main query. Looks like I have 3 accesses to the employee table in this case. So in fact, let's go over to our code environment here. So let me flip over there. All right, and let's come down here and take a look at those. All right, if I get my mouse to cooperate here, there he goes. All right, here's all the code from the previous ones, but here's the one, here's the first one that we're looking at with just the subqueries here, the correlated subqueries, 2 correlated subqueries. We run it. All right, hey, that looks pretty good. So I'm getting I'm getting employee number, job, department number, and salary here on the left down below, and then the average salary for their department. So you'll see some of those repeat because some people are in the same department. Okay, that's great. It works. We're satisfied, right? The query up here might look pretty readable, looks okay to us. But let's take a look at the execution plan for it. There's all the vendors you can do execution plans in. All right, let's take a look at this one here. And this is one way to do it. This is in Oracle, by the way. There's other ways. We have it up here in the GUI too, but I kind of like this way in text. All right, so here's the execution plan for that double correlated subquery. All right, and we'll look at down here. I'm not too worried about that. We're not going to talk about execution plans a lot in this class. So we could fix this up so it's a little bit more with a different font, so it's a little bit more readable. But what do we notice down here? Here's a full table scan, full table access on employee. Here's a full table access on employee. And down here, here's an index access on the employee table. So the only thing I'm wanting to see here, even though it's all kind of all messed up, I just changed the font right before the webinar today. So it doesn't look real pretty here, but I can see just off the bat here with my eyeballs that it accessed the employee table 3 times. All right, let's just go directly here to the next example in the slide deck, and I'll go back to it. Let's rewrite it as a common table expression. Here it is here. All right, here it is here. With clause E2, it's getting what? The average salary by department. That's what the common table expression is doing. In fact, if we just run that by itself, and we can just highlight that by itself, here's the average salaries by department down below. Now down here in the main query, which is this guy, we're going to refer to this E2 up here. Where do we refer to it? Well, here's in our from clause, we're doing a join between E1 and E2. We're referring to this column, which is not in the employee table, but that's this average salary from up here above. And then we do the comparison. Is that person's individual salary, is it greater than any of these down here, these department salaries that you see down below, these guys down here that I'm highlighting? Okay, so that gives us the same results when we run the whole thing, but let's look at it with the explain plan, even though it looks all jumbled up there. All right, so let's look at it with this. Let's run it through here and see what this plan looks like. We'll do that, we'll do that. And if we look down here below at this mess down here, where do we see employee table? There it is there. There's an index access to employee table. And then here's a full access to the employee table. It's a full table scan. That's it. There's 2. So by moving it up above, then it runs what? It runs first. It puts the results in memory. It puts a pointer to that. Then down below in the main query, we refer to that E2 twice up there, but it doesn't have to run it twice like the subqueries did. It only had to refer to it as once because it had already run. The results were already in memory. So when it goes up there and says, oh, I don't need to run it again, here's the results up here. So that's where you get your performance gain, is the more times the main query or the query, whatever you want to call it, accesses or refers back to whatever you have up in your common table expression, that's where the benefits come into play. All right, keep that in mind. These are good simple examples here. So here's the CTE on that. Notice it. I still want to display the department average. Before that was an issue, and I still have to do a join to E2, and I still want to compare to the department average down below, down here. All right, now we've already seen some of the alternatives. Let's look at these before we wrap up today. So we've seen these. Let's go into here. So here's a problem that all 3 are going to try to solve. You kind of do your own judgment on these. Display the department with its total payroll for the department with the highest payroll. All right, so I need to calculate total payroll by department, and then I need to find which one has the highest. And you know, and I know there's more than one way to do it, even more other ways besides what you'll see here today. But here's the NTE example. I mean, just taking a look at it, I don't know about this one, right? We have a subquery here. You see the arrows on the screen. subquery in the from clause, remember that's an NTE, a nested table expression. It's a select in the from clause. That's what I call it. Yeah, rather than saying, oh, it's a nested table expression, an NTE or something else. If you ask me what it is, oh, it's a select in the from. Okay, that's exactly what it is. But anyway, you can see what the code looks like. And we'll run some of these here as after you look at all three of them. So here's the NTE example. Here's a subquery example. Oh boy, here we go again. Here's a correlated subquery up above. I've got a non-correlated with a correlated subquery or a non-correlated embedded down below, down here at the bottom. You know, all these, anytime you see a subquery or a query, a select embedded in another select, and it's not a common table expression, for example, it's going to run every time it's referred to. You know, so this one up here is going to run at the top, and then this one down below is going to run. There's nothing being shared between those two. They're both going to have to run, and that's the bad part about this guy. And then, of course, we could also do, here's one we haven't talked about, but I kind of like this one. We could solve that same problem by creating a database view. All right, what does that mean? Database view. Some of us know what those are. Well, take a look here. Create view. And what does the view do? It selects the department total by department. Now, this one's kind of nice because it kind of looks like the with clause, right? The common table expression. But what's the difference between the two? Let's just flip back and forth here. We can see that. The create view is we're going to create a database object. And it's stored in the database. What's good about that? That means we can share it with any code that we give access to it. Oh, you need access to some code that computes the total payroll by department? I got a view that does that. Here it is. I'll give you permission to it. And then down below is how you access it. The name of the view up here is department pay. Down here we do from department pay. Okay. Now, the only kind of bad part of this is maybe you're in a position where you don't have the privileges to create views. Oh, I can't create a view. You know, I'm an application developer. The DBAs create all our views. Maybe application developers do in some environments, they do, but maybe not in my environment. So yeah, I don't have the authority to do that. But I wish I did. But if I don't, I still have authority. Let's clear this off here. I still have authority to write the CTE because that doesn't take any extra privileges. So look at this one. Here's the CT up above. What does it do? It gets the total payroll by department. Well, that's what the view did. But with this, I don't need any extra privileges to create the CTE. With the database view, I do. Then down below, look at this query real close here. Have you seen that before? Look on this page. It's the exact same thing as with the view. The query down below is exactly the same. The only difference is the definition of the code up above, department pay, with the CTE, this is another benefit to it compared to a view, is I can see what the definition of department pay is here. Back here on this guy, once you create the view, this code, you can't see it on your screen anymore. It's gone. I mean, it's there until you log out. But when you come back in tomorrow, you can't see the definition of the view. I mean, you can look it up, but you have to do extra steps to do that. Okay. So then here's your last one here, the CTE. So, you know, what can we say about these things, these three, the different benefits of it? You know, readability wise, you be the judge on that. Okay. Especially for more complex subqueries in your main query that you want to pull out and move up above, I think you're going to see an improvement in readability. Performance wise, it depends. Right? How many times are you going to refer to that common table expression, you know, down in your main query? And then alternative wise, we know that we can do what? A nested table. Now, I ran through some of the performance tools, and here's what I found, just so you kind of know, and it would be different for different people. I found this should be no surprise, maybe, the common table expression for some of these examples in here compared to their alternatives was 45% faster, than the subquery example. Because remember, the subquery was correlated. And we had 2 of them, and each one has to run multiple times. We moved it up above, and it became a non-correlated subquery, which means it ran once, and we refer to it multiple times, the results. So that should be no surprise to us. 45% faster when I ran it through some of the Oracle tools to measure performance. So it found the CTE to be 45% faster in this case to a subquery example, which had multiple correlated subqueries. Okay. Now you might be thinking, who in their right mind would write multiple correlated subqueries? Okay. But we're just trying to demonstrate that here. And then I found the CTE to even be faster than the nested table expression as well, about 18% in this case, when I ran them through the tools there. So, what can we take away from today? Common table expressions, CTE, subquery factoring clauses. What they allow us to do is take maybe complex or simple subqueries out of the main clause and define them separately up above our main query, prior to our main query, to allow us to focus on them and see them. It's like you pull out a piece of the puzzle to see if the puzzle makes any more sense now, right? And I can focus on just that piece, for example. So it allows us to see those as it in their own kind of world, rather than embedded in a bigger piece of complex code. So that's a good thing there. So readability might be a good thing for us. Like I said, if you have alternatives, do people typically choose the CTE first? I don't think so. Maybe you do, and that's great. But a lot of people like nested table expressions. That's what I've run across. People tend to avoid correlated subqueries because they run multiple times, and it could be a lot of multiple times. But CTEs is kind of overlooked a little bit. It's what I found. That's kind of why we were doing this little webinar today, which we're about ready to wrap up. And then, of course, performance, maybe you get it, maybe you don't. It depends. That's kind of the mantra for anything when we talk about performance, right? Which way is faster? Oh, it depends. What does it depend on? A lot of different things. Depends on what the context is. So that's kind of what we wanted to cover today for everybody. We kind of wanted to introduce what a common table expression was, so you can recognize it syntax-wise. We wanted to introduce the different terms are used to relate to it, and then cover some of the benefits. Readability, and there's really just 2 main ones. You'll see a few others maybe listed here and there, but readability and we'll say maybe readability, because remember that was subjective, and then maybe performance. That depends on how it's used. I really appreciate all of you being here today. I know it's Friday. That's a big day of the week. So thank you for coming in today. Hopefully you found something in here that kind of maybe caused you to think a little bit. That's one of the other things about training is, yeah, we go to training to learn stuff, but it also is supposed to spark some questions in our mind, maybe when we get back to work. I couldn't think of this question today, but now that I'm back at work and looking at this problem, now maybe I have a question, and that's where we come into play. There, just send us an email, and we'll get back to you. All right, at this point here, I'll turn it back over to Marcy to kind of wrap things up.
Thank you, John.
Here at the
I
end.
do have a couple questions that came in. Can one entity refer to another entity in the same with clause?
Oh, okay, that's a great question. Let me go over here real quick just to kind of show you that. I have one. It's not part of the slide deck, but I threw it in here just in case that thing came up. Take a look at this one here up on the screen. Let's get rid of this junk down below here real quick, just so you can see an example of this. Here it is down below, this guy right here. All right, look what we got up here in the with clause. I have one called department cost. That's getting what? The sum of the salaries by department. And then I have one down here called the average cost here as well. And look what the average cost refers to. The department cost, it refers to that, and it refers to back up here to this. Okay. So yes, a If you do have multiple entries in the width, one can refer to the other. And then down below, I refer to department costs, but I also refer to average cost. And what does average cost do? It refers back to department cost. Now, this example is showing us what? The sum of the salaries by department, but it's only showing us those departments who their sum or their total is greater than the average of all the departments. That's what this one's doing here. So yeah, you can do that.
Perfect. We got another one that came in is what is the difference between CTE and creating a temp table using into #temp table?
Okay. Yeah, and all the vendors do temp tables a little bit differently. That's one thing. They're actually very similar. Sometimes a CTE, I've heard people call CTE a temp table because it's the result of it is kind of the same thing, but it doesn't actually have anything physical with it. You know, a temp table depends on the type of temp table. It looks like from the question that I saw there that was referring to SQL Server. Some of the vendors have different types of temp tables. SQL Server does as well. But a table actually gets created, you know, and the data that's in it is temporary rather than the table itself. Now, depending on the type of temporary table it is, that temporary table could go away, could stick around. That, you know, that's kind of misleading when we say, oh, it's a temporary table. Oh, it's going to go away. Well, with a lot of the vendors, depending on the temporary table you create, the table gets created and the data is temporary, but the table's permanent until we do something about it. It's usually created in a special place that's a little bit faster, but they're very similar. Not in some of the vendors, not everybody, it's kind of like with the view, not everybody can create a temporary table. Depending on the vendor, you may need some extra privileges for that. It's an extra step, very similar to the create view. So I kind of look at it that way. So to go back to the question, I'll say, as far as the speed goes, I think you'll see very similar results between the temporary table and the common table expression. All right, Marcy?
And one last one. Will a common table expression always give you a performance gain?
Okay. Yeah, I think we kind of hit on that a number of times there, and the answer is no. Well, we hope it will. We really hope it does, but it doesn't always. It depends on the code from the main query, how often it has to go back and it refers to the results of, we'll say this way for the question from the attendee as well. It depends on how often we have to go back and refer to or access the results of the CTE, or to go back to that question there, the results of the temporary table. So maybe we would, maybe we wouldn't. We just kind of hope that we would. All right, Marcy.
Perfect. Thank you so much, John. Everybody in front of you right now is we couldn't do these without you guys attending, and we love to do our kind of lunch and learn. And thank you for coming today. Again, John said it's Friday. It's a crazy busy day. Everybody's looking forward to the weekend, but we want to make sure that you guys know that we appreciate you guys signing up, registering, and attending. In the coming days, again, we are recording this and we will go ahead and get the recording link out to you probably beginning of next week, along with the slide deck and a brief survey for you guys to answer with questions like, what other topics would you like to have a lunch and learn webinar with us? So look for that in your inbox. That will come directly from me next week. If you enjoy John and his webinars, his classes are just even more fabulous. His upcoming classes, we've got a couple SQL Basic, a SQL Basic, and Advanced SQL. If you want to take the basic all the way to the advanced for the whole days, we also have that you can sign up for both of them at once. And we have a couple other ones with Oracle optimization and database performance. That is on our website, but I will also send this with you in the slide deck. So they are hyperlinks once you get them. So you'll be able to click on them and it'll take you directly to those courses. Again, I want to thank you guys for attending. And John, I also want to let you know, thank you for putting this on for us. And I've learned a few things myself today.
All
So
right.
thank you. Thank you so much.
All right, wonderful. I know if we have just one more moment here, I see a question from Mike came in there referring to materialized query tables, just real quick. And very similar. That's another alternative, Mike, and everybody else for that matter, because he mentioned there, looks like it could be better handled via a materialized query table. We know that a materialized query table, we a lot of times use it to store results of queries so that when we run that query again later, it can refer to the query table, materialized query table, rather than going back to the main database tables and having to recalculate something, right? That's kind of what we're trying to solve here too. So Mike makes a good point there. You know, we're trying to go back to the data, not have to run the query every time we want to refer to that query and its data. I just want to refer to it once and get the answer back there. So yeah, Mike, that's a good question. You're absolutely right. Materialized query tables, that would be another option. Depending on the vendor, somebody again might have to have permissions to create those, or maybe they've been put into place already by the DBAs. So yeah, thanks for the question. That's a good one. That's another good alternative to what we saw today.
Thank you again. Everybody enjoy your weekend and have a good rest of your Friday.
All right. Good day, everyone.